Alright, so day 20 is about the quadratic formula and its discriminant. You may have heard or used the quadratic formula before, so hopefully this will be just a review for those others. This may be brand new. So the quadratic formula can be used to solve any quadratic equation. We solved quadratics by factoring, we solved quadratics by taking the square root of both sides, we solved quadratics by completing the square. This is the fourth one, and this will work with any quadratic. So the ones that we factored, we were able to solve by factoring because factoring worked for that specific problem. But for other problems we couldn't factor, we had to use a different method or this quadratic formula. That doesn't mean that there are equations that can only be solved by factoring but not by quadratic formula. It's one of those things where quadratic formula works for everything, and then the other methods work in those special cases. So like I said, we use the quadratic formula when we can't have equations be solved by factoring or completing the square. Now you might say, well, why don't we always just use quadratic formula then if it always works? Well, here's the quadratic formula right here. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So there's a lot more that goes into the quadratic formula than, say, factoring. So it's kind of like our method of last resort here. So down here I want to talk about a specific part of the quadratic formula. The part b squared minus 4ac, that is called the discriminant, and that will tell you the number and type of solutions we have. Remember, for these quadratic equations, we could have two real solutions, one real solution, or no real solutions, which means two imaginary solutions. The discriminant will tell you how many and what type they are. So another way of thinking about the quadratic formula is negative b plus or minus the square root of the discriminant all over 2a. Now, if that discriminant, so the number underneath the square root, is a perfect square, then that equation is factorable. And you could say, well, let me stop doing the quadratic formula and go ahead and factor it because that might be easier. So if the value of the discriminant is positive, that means we have two real solutions, and our graph would touch the x-axis twice. If the value of the discriminant is exactly 0, there is one real solution, and we have our quadratic whose vertex is on the x-axis. It only touches once. And if the value of the discriminant is negative, then there are two imaginary solutions. And you see that this graph does not touch the x-axis at all. Now, these graphs are all oriented upwards. This would also be the case if they were reflected down. If you don't touch the x-axis, that means you have no solutions. So let's look at these examples down here where we're going to solve using the quadratic formula and note the number and type of solutions. So we're going to use that discriminant. Now, the quadratic formula must equal 0. Up here, probably should have highlighted it. Must equal 0. Equals 0. So our first example does not equal 0. So let's add 16 to both sides. That will get us 2x squared plus 12x plus 16 equals 0. Now you might be looking at those numbers and say, oh, they're all even. Can we factor out a 2 or divide by 2? Yes, you can. You can divide everything by 2, and that might make things a little bit easier just because now we're dealing with smaller numbers. So let's go ahead and divide everything by 2. So we have x squared plus 6x plus 8 equals 0 divided by 2 is still 0. So now let's use that quadratic formula. And remember, the number in front is a, so a is 1, b is 6, and c is 8. So x equals negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a, which is 1. Okay, so then this is equal to negative 6 plus or minus. We're going to get that value of the discriminant. Okay, so there we go. So 6 squared minus 4 times 1. I know we don't have to type times 1, but I did anyway. And we get 4. All right, so this tells us a couple of things. One, since that discriminant is a positive number, we know there are two real solutions. We don't know them yet, but we know there are two real solutions. Now, that is also a perfect square. 4 is a perfect square, so that means I could have solved this problem by factoring instead. Well, let's keep going with this. So x equals negative 6 plus or minus 2 over 2. Now, all of those numbers are divisible by 2. Negative 6 divided by 2 is negative 3. Plus or minus 2 divided by 2 is 1. So we get negative 3 plus or minus 1. So our two solutions will be negative 3 plus 1, which is negative 2, and negative 3 minus 1, which is negative 4. Okay, so finding that discriminant will tell you kind of what to expect. All right, let's look at the next one. Again, this doesn't equal 0 just yet. So we're going to subtract 7x from both sides and add 25 to both sides. This will give me 4x squared minus 20x plus 25 equals 0. All right, we can't divide everything because 4 is not divisible by 5, so we can't do that. So let's just go right to the quadratic formula. X equals negative b, so negative 20 plus or minus the square root of b squared, so negative 20 squared minus 4 times a, which is the number in front of x squared, so 4 times c, which is 25, all over 2 times a, which was 4. So if we type that discriminant into the calculator, parenthesis, negative 20 squared minus 4 times a, which is 4, times c, which is 25, and we get 0. Okay, so this is positive 20 because negative becomes positive. So 20 plus or minus the square root of 0 over 8. Now, because the discriminant is 0, that means there is one real solution. The square root of 0 is just 0. So we get x equals 20 over 8, which can be reduced to 5 over 2, and that is our only solution. And I like to look at the discriminant when I do this because let's say I got this, I say, okay, there's one real solution because the discriminant is 0, but I have two different x's in my solution. I know I did something wrong, and I should go back and fix it. All right, last example before I have you try some on your own. Now, we can subtract 5 from both sides and give us negative x squared plus 2x minus 5 equals 0. And I know when we talked about factoring and completing the square, we emphasized that our a value should always be positive. Well, with the quadratic formula, it doesn't matter if a is positive or negative, as long as you use everything else correctly. So our a value in this case is negative 1. So x equals negative b, so negative 2, plus or minus the square root of 2 squared minus 4 times a, which is negative 1, times c, which is 20. Sorry, a was 5, not 20. All over 2 times negative 1. So x equals negative 2 plus or minus, that's going to be negative 16 over negative 2. Now again, this discriminant tells me because it is discriminant, the number underneath the square root, because it's negative, that means there are two imaginary solutions. So I need to have I in my answer. So x equals negative 2 plus or minus, well, the square root of negative 16, well, the negative comes out as an I, and the square root of 16 is 4, so 4i over negative 2. Now I can simplify this because all of these numbers can be divided by negative 2. So x equals 1 plus or minus 2i. Now, I know negative 4 divided by negative 2 is negative 2, but because there's a plus or minus in front of it, it doesn't matter. It's not going to change because it's still plus or minus. All right, so if we look at these two, I'm going to ask you to pause the video, try these two problems the same way we did them up here, and when we're done, unpause it, see if we get the same answer, and then we can move on. Alright, so let's look at this one here. First I subtracted 6 from both sides, and then I threw it into the quadratic formula, and when I did that I got negative 7 plus or minus the square root of 73 over 2. Well, 73 is positive, so that means there are two real solutions to this, and then I looked and asked myself, can I break up the square root of 73? No, you can't break up the square root of 73, so we can't go any further in that part. Can I simplify the negative 7 over 2? Nope, that can't be simplified, so this is your final answer. Then on this one, same idea, we get this equation equal to 0 by adding 2 to both sides, and then throwing that into the quadratic formula. This time, though, I got negative 8 plus or minus the square root of 80 over 8. So that means there's two real solutions. Square root of 80 is positive. But now I can break up the square root of 80. Remember, the square root of 80 is the square root of 16 times the square root of 5. Well, the square root of 16 is 4. So that's how I got 4 times the square root of 5. And now those three blue numbers I highlighted, since they're all divisible by 4, I can reduce that by 4, and that's how I got negative 2 plus or minus the square root of 5 all over 2. Now, I want to discuss real quick which examples would be more appropriate for quadratic formula versus other methods. Well, the first one we did, factoring would have been easier. After we divided by 2, you should have said, oh, I know my two numbers that add up to 6, but multiply to 8. That would be positive 2 and positive 4, which means my solutions were negative 2, negative 4. That probably would have been easier. This one you could have factored if you realized it was a perfect square trinomial. You could have factored that and then square rooted both sides. But the quadratic formula didn't take that long either. Example 3, quadratic formula all the way because we had imaginary solutions. Now these two, I would say quadratic formula would work better because these are non-factorable And completing the square is more efficient when you have a b value that is even and an a value that is 1. So the first pair problem has an a value of 1, but b is odd. So completing the square would look a little more messy. And the solo problem does have an even b value of 8, but a is 4, which again makes that a little bit messy. Still doable. You can still complete the square with both of these, but quadratic formula was a bit easier. All right, so on to the next page, our vertical motion problems. We're going to revisit those because now that we can use the quadratic formula, we can expand our knowledge base. We had originally talked about this formula when an object was dropped. Notice there's no t to the first power. It's just negative 16t squared plus h naught, or the starting value or starting height, and we could solve that by using square roots. Now that we have the quadratic formula at our disposal, we can use this formula, and notice how there's a v naught times t. And that t is raised to the first power. That v naught is our initial speed or velocity, and h naught again is our initial height. T is time and h is our final height. So example 5, it says a juggler tosses a ball into the air. The ball leaves the juggler's hand 4 feet above the ground, so that is our h naught, and has an initial velocity of 40 meters per second. This is v naught. Write a model for this situation. All right, so we can look at that second highlighted yellow equation. H is equal to negative 16t squared plus v naught times t, which we now know is 40, so 40 times t, plus h naught that we now know is 4. So that would be our quadratic equation. B, the juggler catches a ball when it falls back to a height of 3 feet. How long is the ball in the air? So because it says a height of 3 feet, that's what it is equal to. So 3 is equal to negative 16t squared plus 4t plus 4. So now we can use the quadratic formula for this. It is going to give us some potential ugly numbers, but that's okay. Subtract 3 from both sides. We have negative 16t squared plus 40t plus 1 equals 0. Okay, now we can use the quadratic formula. We have negative b, so negative 40, plus or minus the square root of b squared, which is 40, minus 4 times a, which is negative 16, times 1. All over 2 times negative 16. So we type in that discriminant into the calculator. So 40 squared minus 4 times negative 16 times 1, and we get 1,664. So negative 40 plus or minus the square root of 1,664 all over negative 32. Now, because we are asked to round to the nearest hundredth, I'm not even going to bother with trying to simplify that radical. I'm sure it's divisible by like 4 or maybe something like that, but let's be smart and use our calculator since we're allowed to. So negative 40 plus the square root of, whoops, all right, let me go about this a different way. We're going to do a fraction, so alpha y equals negative 40 plus the square root oops, the square root of 1,664 over negative 32. So I'm doing the plus one first, and we get negative 0.02. Then I'll do the negative one to go back up here, change this plus to a negative, or subtraction. We get 2.52. So my two solutions, x equals negative 0.02 and x equals 2.52. Well, which one do we pick? Well, the negative one doesn't make sense in the context of the problem because we're talking about time. Time can only be positive, so 2.52 seconds. Now, another way we could have solved this was the graphing calculator. And our y1 could have been the original function, and y2 would have been what it equals 3. And we could have done the second trace and intersected those to see what our solution is. All right, so that's it for the quadratic formula. It's a very powerful tool now that we have it. We can use it to solve any quadratic. We just have to be very careful about our positives and negatives, making sure we input those correctly to get the desired answers. So thanks for watching. Make sure to like and subscribe.